Hello and welcome back to the channel. Today we are heading deep underground, nearly a mile below the Earth's surface, to explore one of the most ambitious scientific projects of our time. This is the story of the Deep Underground Neutrino Experiment, or DUNE, a monumental research facility that may uncover secrets as strange as extra dimensions, beyond our known universe. Let's dive into what this is all about. Neutrinos. These ghost-like subatomic particles have fascinated scientists for decades. They are incredibly small, so small, in fact, that they are often described as having nearly no mass and no size at all. They were born shortly after the Big Bang, nearly 14 billion years ago, and continue to zip through the universe by the trillions, every second passing through matter, including your body, without a trace. But these tiny particles might hold massive answers, because neutrinos can change between three different forms: electron, neutrino, muon neutrino, and tau neutrino. Scientists believe that studying their transformations could help us answer one of the biggest questions in physics. Do hidden dimensions exist beyond our familiar three of length, width, and height? To find out, the United States is constructing one of the most advanced underground laboratories ever built. It is called DUNE, and instead of being contained in one location, this experiment spans a colossal 810 miles across the Midwest. At one end of the project, just outside Chicago, sits the famous Fermilab Research Center. Here, scientists are building what will be the most powerful particle accelerator in the world, PIP-2. This machine will fire a beam of high-energy protons nearly at the speed of light, smashing them to produce a stream of neutrinos. Once created, this beam will travel through a small detector, located right at Fermilab, and then incredibly continue traveling through solid rock all the way to a massive underground lab nearly 2,500 meters, or about 4,900 feet beneath the surface in the Black Hills. No tunnel is needed. Neutrinos do not interact with matter, so they simply glide through the Earth as if it were air. At the other end of this beam lies the Sanford Underground Research Facility, a former gold mine that has been transformed into a high-tech science hub. To make room for the experiment, crews had to excavate over 880,000 tons of rock, carving out three enormous underground caverns. Each cavern is longer than a football field, with dimensions of 500 feet long, 92 feet high, and 65 feet wide. In these caverns, researchers are installing two giant neutrino detectors, cooled by 17 tons of liquid argon. Why argon? Because when a neutrino interacts with argon atoms, it leaves behind traces that detectors can record. The third cavern houses power systems and cooling infrastructure. Now imagine this: the neutrinos fired from Fermilab will travel 810 miles underground and arrive at Sanford, where scientists will look for signs of transformation or oscillation between the neutrino types. These subtle changes, if measured precisely, could suggest that neutrinos are slipping between dimensions we cannot see. This is not science fiction. According to leading physicists, the way neutrinos morph as they move could be influenced by forces that originate in dimensions beyond our own. DUNE's mission is to track and understand these oscillations, potentially finding the first hard evidence that more than three spatial dimensions exist. To achieve this, DUNE's detectors must be incredibly sensitive, and the accelerator must be immensely powerful. The proton beam from PIP-2 will be one of the most intense ever built, designed specifically to produce the brightest possible stream of neutrinos. Construction of the underground facilities was mostly completed in 2024, including heavy concrete reinforcement for the cavern walls and floors. Now, scientists and engineers are in the process of installing the detectors and finalizing the accelerator systems. The project is expected to begin full scientific operations in 2032. And while that might seem far off, this timeline gives scientists time to test, calibrate, and prepare for what could be one of the greatest discoveries in modern physics. So why go to such lengths or such depths to study a particle that is almost invisible? Because neutrinos are messengers from the earliest moments of the universe. Understanding them might reveal why matter exists at all, and whether there are hidden forces shaping the cosmos that we cannot yet perceive. If DUNE succeeds, we may one day look back at this project as the moment humanity took its first steps into dimensions beyond imagination. Thanks for watching. If you are fascinated by deep space, cutting-edge science, and the mysteries of the universe, be sure to like, comment, and subscribe. We will keep bringing you stories from the frontiers of science and technology. Until next time, stay curious.